Okay, hello to anyone watching. So this is question 3 from the Madas Maths paper U. Yeah, quite a tricky one, particularly at the end where you've got the conditional probability coming in. They're doing that more often though now. It's something you definitely want to be on the watch out for. So it's a good question, this. I like the way it's done actually. It looks slightly different to some of the other conditional probability questions I've seen in past papers. Not necessarily more difficult, because actually some of the past paper conditional probability with the normal questions have been really tricky. Remember, you won't have to deal with that in the upcoming exam, but nonetheless, I think it's something you should be able to do because it can come up later in your education. Okay, so here we go. The number of miles Mark's motorbike can travel on a full tank of petrol can be modelled where a normal distribution with a mean of 135 and a standard deviation of 12. And the question starts off pretty friendly. And so we've got all the info because all we need to find first is the probability that Mark can travel at least 165 miles. So I don't think it takes too much imagination to see that this is the probability that x is greater than 165. Now nowadays, because of your calculators, nobody ever draws diagrams anymore, but it's going to be mega useful at the end. So you want to get in the habit of drawing diagrams, even though, you know, I know your calculator does all your thinking for you on these simpler questions anyway, but not on the trickier ones. We've got this, we've got 135 in the middle. We want it to be greater than 165. So we want this little bit here. We can just key that into a calculator nowadays. Let me just remind myself how the calculator works. I'm just going to do it on mine. So I go to normal CD, which is 2. I put my lower bound in as 165. I put my upper bound in as like 10,000 or something. I put the standard deviation in as 12 and the mean in as 135. And the calculator just spits out the answer 0.0062. But I very much doubt that that question was what was causing you difficulty here, because that one's very, 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 standard kind of stuff. The next one may well have done, because the next one is slightly confusing, a fair bit confusing actually. It's one of these ones where it's pretty obvious we've got to use the inverse normal though. We're finding to the nearest mile the longest journey that Mark can make if he is to have at least a 90% chance of completing it on a full tank of petrol. Now, this one's not so bad, provided once again you're willing to draw a diagram. Yeah. Now I'm just going to draw the same diagram as above, really. But this time I'm given a probability and I'm asked to find what I refer to as Z or X values. Yeah, that's a terrible drawing of the normal distribution, but never mind. It hasn't got to be perfect. It's really just for a thinking aid. Yeah. Now, let me put it to you like this. Surely if he drives 135 miles, surely if the petrol runs out after 135 miles, he's going to have got there if he only uses 120 miles of petrol, 116 miles of petrol, or whatever. Because this is like, if you like, the maximum amount. Yeah, he's going to have a little bit left over. What I'm basically arguing for here is that if he's got a 90% chance of getting there, then this should be on the left of the mean, yeah? And it's because whatever A is, let's say A is 100 miles, yeah? If that's 100 miles, that is the chance of him, that is his petrol actually, his tank actually running out of petrol, yeah? So he goes 100 miles and then he's run out of petrol. Well, if he's gone 135 miles, if he gets 135 miles out of his tank of petrol, then he can travel 100 miles, if you see what I mean. So it all kind of works back to front, this, and that does make the question confusing. There's no doubt about it. But we want to find the value of A for which the probability that X is greater than A is 0.9. Yeah? Or even better, you can restate that, and it's exactly the same thing. Find the value of A such that the probability that X is less than A is 0.1, because that area is going to be 0.1. Yeah, basically it all kind of works back to front to the way your head might think about it. You know, if you think about it, right, if you get a really high value for this answer, what you're saying is that 90% of the time he can travel like 160 miles, even though the average amount he can travel is 135 miles. That doesn't make any sense. This value should definitely be less than the mean amount of miles he can travel with a full tank of petrol, because it's 90% of the time, you know. So yeah, it's easy to get this the wrong way round. Now after that, once you've set up the equation correctly, bearing in mind that the normal distribution on your calculator only works for less than statements, so you definitely want to use this second statement here. Yeah, only works for less than statements, the inverse normal. We can then just say the area is 0.1, standard deviation is 12, mean is 135, and once again we get the answer just spat out at us, which is why I don't like the calculator actually, because it doesn't encourage understanding on normal distribution. Now that's 119.6 miles, but they did say round to the nearest mile, so A should be 120 miles. I must admit that's where I disagreed with the mark scheme, because he said it's 119. It's like, no, you wouldn't round down there. It's closer to 120 miles. If anything, you should round up because you don't want to break down. Rounding down means you're going to break down. That's no good. Okay, so that's that one. I hope that's clear now. Now the last one's really tricky. Uh, Okay, firstly, I know it's going to be tricky because it says given that. Yeah, given that is a dead giveaway for conditional probability. We're using conditional probability here, so we want to write down a conditional probability statement. Given that Mark has a 90% chance of completing his journey on a single tank of petrol. Well, that's cool. You know, we know what that statement is all about. It's about probability that x is greater than 119.6. Yeah, basically, and then you've got a 90% chance of completing the journey. Find a probability that this journey will not exceed 165 miles. Okay, I'm going to try and model this, yeah? What I want to find here is the probability that x is less than 165, given that x is greater than 119.6. Yeah, and let me explain why. Yeah, let's go back to the actual statement. With conditional probability, we always want to, given that statement, let me point out firstly that probability of A given B, what you're given comes second, yeah? So what were we given in the question? We were given that he's got a 90% chance of completing the journey. And if he's got a 90% chance of completing the journey, then the part B holds, if you like. Well, part B holds if you've got probability that x is greater than 119.6. That's what gives you the 90%. Yeah, you need to find a probability that he's going to drive for at least 119, or if you like, you need to find the probability that he's got at least enough petrol in his tank to last 119.6 miles. Yeah, so it could be 135 miles, it could be 165 miles, but we need to make sure he's got a 90% chance of going through the whole journey. So that conditional bit, the given that should be x is greater than 119.6. Now let's look at the other bit. Given that Mark has that 90% chance, we've dealt with that. Find the probability that this journey will not exceed 165 miles. Okay, not exceeding 165 miles means he's got 165 miles or less in the tank, and so that should be the probability that x is less than 165. Yeah? That's probably the most difficult bit. I would like to draw a little diagram though, because I like the little diagrams in normal distribution. It's the only way to get it right, especially the tough bits. It encourages understanding the diagram, even if it's just a naff old, straightforward little bell-shaped curved diagram. Right, okay, so we can actually do a lot with this diagram because we've got a lot of the values. Right, what conditional probability? The way it works is probability of A given B is probability of A and B over P of B. I never forget that. That's dead useful, that formula. It's really, really good. So what do we want on the top? We want the probability that x is less than 165 and let me give myself a little bit of room here and rub out this a little bit, maybe make that a bit smaller because it's useful to see that written down. There we go. Okay, and x is greater than 119.6. All divided by what you're given, which is the probability that x is greater than 119.6. So all I've done is unthinkingly applied this formula. Yeah, formulas are there to avoid thinking, aren't they? That's the whole point of them. So I've just employed the formula. Now I'm going to use my diagram though. I need to find, if I want x to be less than 165 and bigger than 119.6, I need that area in there. Now remember, that bit from the diagram in part 2 is 0.1, and this bit from the diagram in part 1 is 0.0062. And so what do we need to do? We need to find the area, so we need to do 1 minus 0.1 minus 0.0062. And as for the bottom statement, the probability is greater than 119.6. We've already got that. We know that that's 0.9. we were given that it was 90% chance, so it should be divided by 0.9. Now you can just crunch through the numbers. It comes to like 0.8938 over 0.9, which is 0.9931. Now, whilst that is difficult, I'll guarantee that's come up before, more than once, yeah? That has come up, that kind of question. So look out for those ones. They're tough questions, they really are, but they do get asked in the real thing. That's what I'm saying. It gets asked in the real thing. Okay, so I hope that's made that a bit clearer. It is a tricky question, but it's more tricky not in the algebra, not in the working out, but in the thinking and in looking at the diagram and really understanding what it represents. I think even in part 2 it can get quite confusing as to why that value should be to the left of the mean, and it's because if your if your car doesn't go very far, then you're not going to get very far. And obviously if you've got a 90% chance of completing the journey, that value should be less than the mean. Okay, I hope that's helped, and yeah, best of luck and keep going with the hard work.